Hi, I'm Stevie C and the place to be. This video is about my current obsession with VU meters. Having studied sound engineering at college, always having had a fascination for interactive lighting, whether it be sound to light or DMX controlled, and having an appreciation for old hi-fi equipment and pretty much all of Techmoan's videos, and of course loving loud music, it's hardly a surprise that I've gotten into these. I was having a look on eBay for a second-hand Dorrough meter, or even a brand new one of dubious origin, saw the prices and thought, yeah, nah. I've called this PCB prototype Dorrough the Explorer. It was obviously inspired by Dorrough meters, and just like Dora the character, this PCB has helped me explore the op-amp circuitry required to make this project operate as desired. If I were to make these available, I'd have to change the name for obvious reasons. The LEDs are styled to look like an EQ curve from my DAW, and the drive circuitry was copied from the relevant datasheets and splatted into Sprint layout. There's 3 ICs on board, an LM3916, an LM386, and an L785 CV. The LM3916 is a self-contained VU meter IC comprising a comparator network which, as the name suggests, compares an analog input voltage level against another voltage reference. As the voltage level increases, each LED stage turns on. It functions similarly to the LM3915 and LM3914, except for the scale to which it represents voltage level, so in theory they'd be cross-compatible, although I haven't experimented with this. The input voltage level comes from either an external source or this onboard electric microphone, which has to be amplified to be of use to the VU meter chip. So that's where the LM386 comes in. The mic is connected with a current limit resistor, a capacitor, and a potentiometer, which forms a voltage divider with adjustable gain level. The 386 has several support components, such as these capacitors and resistors, which form snubber networks to reject high-frequency or low-frequency oscillations, which would be outside the range required. There's also these capacitors for gain control and bypassing to help supply a stable voltage to the chip. I settled on the 386 as I had several dozen of them in stock for whatever reason. I haven't had much use for them until now. As audio is usually AC, there's a diode to convert the audio signal to DC so it's compatible with the chip. There's another diode for polarity protection on the input supply of the PCB. I was exporting the PCB Gerber files for manufacture and having a final idiot check of the LM3916 datasheet when I noticed something mentioning the use of resistors or a voltage regulator for the LEDs with a supply voltage in excess of 5 volts. I hadn't allowed for either, so I hastily copied the footprint of a regulator with its support capacitors from another PCB design and lobbed it in. This switch allows for selection between the two LED display styles, which are bar mode or dot mode. These two resistors are for reference adjustment and LED drive control. During the design stage, I copied and pasted a resistor footprint into the component positions, but forgot to change the values on the silkscreen before exporting the Gerbers. By a happy accident, the circuit still functions and still appears visually acceptable with the current values. You'll also notice that I've used different styles of capacitors between the two PCBs. I was experimenting with film and ceramic capacitors, and apparently ceramics are better for audio. I developed a second version, which is much more compact and is designed to allow the use of an external LED display PCB. It's called VUio because that's exactly what it is, an I/O board for a VU meter display. There's not much to mention about this board, except for the cock-up I made designing the footprint of the DC jack input. You may recall my last video where I demonstrated an LED message panel I called das Volt Zeichen. The second version of that PCB are these individual LED character boards, which can be arranged into any message of any length and any physical footprint. The letters are formed exactly the same way as on the 8x10 das Volt Zeichen PCB, except here each character can be connected into one output on the VUio PCB. In this example, I've used the name of a PA and lighting company from Dundee. You'll see that I've been experimenting with different ways of holding the display together. The individual letters in this example each have a 100 ohm resistor to tame their current and match their brightness to the .co.uk part, which connects into one channel, thus sharing the current between all the LEDs and being naturally dimmer. The second external LED board I want to show you is my attempt to recreate the look of an analog VU meter, and I've called it Analogue of an Analog VU, which I thought was an incredibly witty pun. I got the idea while in a kebab shop of all places, as kebab houses tend not to use real cheese. Instead, most use what's called a cheese analogue, hence the different spellings. Because June is Pride Month, my third and final LED PCB is a Pride Flag VU meter, because you should be loud and proud, or something like that. This PCB is very similar to Big Clive's gallium PCB, except that it fits neatly into a Poundland frame and has a common positive bus bar with separate neutrals for connection into the VUio terminals. Each LED has to have a resistor like in the original gallium, because otherwise the low voltage LEDs, i.e. the red or orange, would cap the voltage and not allow the green, blue or pink ones to light. And just because I could, I've used this glass and acrylic paint to colour some white LEDs for a more vibrant yellow than standard yellow LEDs. Although these VU meters could technically be calibrated by use of the potentiometer and a reference tone, they probably won't be as accurate as a professional meter and should be treated as a novelty, as technical art, as interactive decorations or whatever. Hopefully I've been able to use my basic electronics skills to inspire someone else as much as I have been, and to demonstrate that you can pick a project that appeals to you and just dive in with a PCB design package, datasheets, components, a soldering iron, etc. I personally can't seem to learn something if I'm not inspired by the subject and or have no practical application for the knowledge. Maybe that's a me thing or an ASPE thing, I don't know. The rest of this video will be my little collection of VU meters doing their thing to the YouTube audio library in various light levels. I may consider uploading this bit separately. Obviously, due to the slightly different angles and distances of my speakers from the individual VU microphones, there may be some slight difference in audio level between the different meters, but despite the minor differences, the lights will go on and off and it's nothing to worry about, it's a simple thing, etc. If you enjoyed this project, like, share, comment and subscribe, and I'll see you next time. Thanks for watching.